A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. So we have chatted in previous episodes about AI engineering and the building blocks of AI and really how important and I think transformative context is. I think it's really if I were to pick one ingredient that I would say, if you can dial down on this, figure out a way to get more context into your prompts, that's going to make a bigger difference than prompt engineering and trying to perfect the prompts themselves. That would be my advice anyway to someone. And that's led to a lot of experimentation I've done with mechanisms for trying to proactively develop context and even find or develop personalized AI systems in which the AI tool builds up this long-standing memory about you. And to an extent, context is actually used in this episode, in this podcast. Sometimes you'll reference previous episodes. If anyone's wondering how that works, it is a context injection pipeline within the production pipeline. But the challenge from our podcast standpoint is that we record in a database all of the episodes we produce, including beyond the audio artifacts, my prompt, a summary version of my prompt. I think the database has about 30, if not 40 columns at this point. The episode description, everything is recorded and logged. But the episode transcript, the actual dialogue between you two, Herman and Corn, if you were
Continue on to Queen Schlomzion Street.
If you were to take that text and multiply it 800 times, or however many episodes we produced, it's a huge sea of text to go through.
Continue on to Queen Schlomzion Street.
Sorry for the Google map interjection. I better check where I'm going. Now you guys have another vantage point into how my word prompts is produced. See, it really is me out here on a street, Schlomzion Street, just kind of thinking about things and sending them in your way. I'm on the way, if you were wondering, to Eucalyptus in Jerusalem, which is having its closing.
Turn right onto Shlomo HaMelech Street.
So Herman and Corn, the sea of context is very big, and if we were to the mechanism we use for RAG at the moment is kind of
turn left onto
reactive in a sense.
Street.
We have an AI system like the AI agent that supervises the generation of these episodes, and if the agent says, oh, this might be a good time to ingest context from our previous episodes, it will do so. But it's not, to me, we're still actually too wedded to the traditional search model by which traditionally, until very recently, we received information by running keyword searches in Google, and that was just how it was done. And I think maybe some of the way we implement RAG is wedded to that approach. What would really interest me, and we're talking again at the level of AI engineering and tooling, is a more intelligent way of doing RAG, by which I mean we have the planning agent in the podcast production pipeline, we have the vectors, we have the embeddings of all the episodes we've done previously, and I'd love to have a RAG work pipeline in which the agent says, here's Daniel's prompt today, here's basically everything relevant from the podcast history. So in other words, instead of doing reactive query-based polling against the vector database, it's doing a kind of more holistic ingestion across a huge amount of context data. Because I'm thinking this podcast, 8 or 900 episodes is not, it pales in comparison to what an enterprise might have in its own vector database. So we're still talking about a very small level of scale. But I'm wondering, in the retrieval side of RAG, what are the differences in approaches that we already see? We've talked about Pinecone and all the different embeddings and how those work and the mechanics of RAG. But I'm always curious about the retrieval aspect as to whether there's just one way to do it or there are different methods, because I think that a lot of when context works well, it's often not because there was that context in the vector database or not. It's because the retrieval was a lot smarter. Herman and Corin, let's talk about the R in RAG in today's episode of my weird prompts.
Hey everyone, welcome back to my weird prompts. I am Corn, and I am joined, as always, by my brother, the man who has spent the last 48 hours straight reading about vector quantization, graph theory, and the topological nuances of high-dimensional latent spaces.
Herman Poppleberry here. And you are not wrong, Corn. I have been deep in the stacks this week. There is so much movement in the architecture of how these systems actually remember things that I can barely keep up. We are seeing a massive shift in the industry right now, moving away from the brute force approach of just throwing more tokens at a model and toward a much more elegant, structured way of managing information. It is a great time to be a nerd, Corn.
Well, today is a perfect day for that obsession because we have a great prompt from Daniel in Jerusalem. Daniel is a long-time listener and a serious tinkerer in the AI space. He is thinking about the future of retrieval augmented generation, or RAG as we all call it. He is basically looking at the way we currently handle context in this very show, and realizing it feels a bit reactive. Currently, we have an agent that decides when to pull in data from our past episodes, but Daniel wants to move towards something more proactive and holistic. He is asking about the methods for the retrieval aspect of RAG that go beyond just vector databases and embeddings. He wants to know how we get to that long-standing memory feel without the system just waiting for a specific keyword to trigger a search.
This is such a timely question. Daniel is right on the money here. We have spent the last couple of years obsessed with the generation part of the equation, making the model smarter, faster, and more creative. But the retrieval part, the part where the system actually finds the right information to talk about, has remained relatively basic for a lot of implementations. We are still largely stuck in this paradigm of taking a user question, turning it into a mathematical vector, and finding the closest matches in a database. It works, but it is often noisy and, as Daniel pointed out, very reactive. It is like having a library where the only way to find a book is to shout a word and hope the right one falls off the shelf.
It is interesting that he mentions our own internal system. For those who do not know, we have a huge archive of over 800 episodes. When we talk about a topic, our system looks at what we have said before to provide that continuity, but it does rely on a specific trigger. Daniel is pushing us to think about a more intelligent ingestion process. Before we get into the heavy technical alternatives, Herman, why is the traditional vector search starting to feel like a bottleneck for power users like Daniel in 2026?
The main issue is semantic density versus precision. When you turn a sentence into an embedding, you are essentially flattening a complex idea into a single point in a high-dimensional space. That is great for finding general topics, but it is terrible for specific details or complex relationships. For example, if you ask a system about a specific date or a very niche technical term, a vector search might return something that sounds similar in tone but is factually irrelevant. It is also very limited by the chunk size. If your context is chopped up into small pieces to fit into a database, the system loses the broader narrative of the information. It is looking at the world through a keyhole. You lose the why and the how because you are only looking at the what of a single paragraph.
That makes sense. It is like trying to understand a whole book by only looking at individual sentences scattered on the floor. You might find the word apple, but you do not know if it is about a fruit, a computer company, or a metaphor for original sin. So, if we want to move beyond that reactive keyhole-style retrieval, where do we start? Daniel mentioned he is interested in more holistic ingestion.
One of the biggest shifts we are seeing right now is the move toward hybrid search as a baseline, not an extra feature. This combines the semantic power of vectors with the old-school precision of keyword search, specifically things like BM25. BM25 is a ranking function used by search engines to estimate the relevance of documents to a given search query based on term frequency and document length. When you combine them using something called reciprocal rank fusion, or RRF, you get the best of both worlds. You get the conceptual understanding of the vector and the exact match capability of the keyword. But even that is still a bit reactive. To get to the proactive level Daniel is talking about, we have to look at things like query transformation and expansion.
Query transformation. I remember we touched on this briefly in episode 8-9 when we talked about context engineering. Is that where the system rewrites the user's question before it even starts looking for answers?
One of the most powerful methods here is called hypothetical document embeddings, or HIDE. Instead of taking Daniel's prompt and searching the database directly, the system first asks a large language model to write a fake hypothetical answer to that prompt. Then, it takes that fake answer and uses it to search the database. The reason this works so well is that a dense vector of a question often looks very different from a dense vector of an answer in the latent space. By generating a hypothetical answer first, you are searching for documents that look like the information you want, rather than documents that look like the question you asked. It significantly improves the hit rate because you are matching answer to answer, rather than question to answer.
That is fascinating. It is almost like the system is visualizing what the right answer should look like, and then going out to find the real-world evidence that matches that vision. It is a bit like a detective who forms a theory of the crime first, so they know which clues to actually look for in the field. But Daniel mentioned moving toward a more holistic ingestion across large amounts of context data. Does that lead us into the world of graph RAG?
Oh, absolutely. Graph RAG is where things get really exciting and where the holistic part really shines. Instead of just having a flat list of text chunks, you use a model to extract entities, people, places, concepts, technologies, and the relationships between them to build a knowledge graph. Imagine the context as a map of relationships rather than just a pile of documents. When Daniel asks a question, the system does not just find a piece of text, it traverses the graph. It sees that episode 752 is related to the concept of answer engines, which is related to the concept of pigeon English, which is a term we use to describe how people talk to search engines. It allows for multi-hop reasoning. You can find information that is 3 or 4 steps away from the original query, but is contextually vital.
I can see how that would feel much more proactive. It is not just waiting for a keyword match. It is understanding the structure of our entire conversation history. It feels more like how a human brain retrieves memories. We do not just search for a word, we follow a trail of associations. If I think about my childhood home, I might then think about the tree in the backyard, then the tire swing, then the time I fell off it. A vector search would just find childhood home. A graph search finds the tire swing.
Precisely. And Microsoft Research has done some incredible work on this with their GraphRag framework. They use a technique called community detection. They take the whole graph and group related nodes into communities at different levels of granularity. Then they generate summaries for each of these communities. So, when a user asks a broad, holistic question like, "What is the general philosophy of my weird prompts regarding AI safety?" the system doesn't have to search every single episode. It looks at the high-level community summaries that represent the AI safety cluster of our show. It provides a much more comprehensive and synthesized answer than a standard RAG system ever could.
That sounds like it solves the lost in the weeds problem. But what about the structure of the documents themselves? Daniel is talking about long-standing memory. Does that involve how we actually store the text?
It does. That leads into another method called hierarchical RAG, or parent document retrieval. This is a way to solve the chunking problem I mentioned earlier. Usually, we chop text into small bits, say 300 words each, so the vector search is precise. But 300 words often isn't enough context for the LLM to understand the nuance. With hierarchical RAG, you store small chunks for the actual vector search to ensure high precision, but those small chunks are linked to much larger parent documents or even the full transcript. When the system finds a relevant small chunk, it does not just grab that sentence, it pulls in the entire surrounding context of the parent document. This gives the model the big picture that Daniel is looking for. It allows the system to be holistic without being overwhelmed by noise during the initial search phase.
So, instead of just getting the one sentence where we mentioned a specific technology, it pulls in the entire 10-minute discussion about that technology. That would definitely make the AI feel more like it actually knows us and our history. It is like if I asked you about a specific person, and instead of just giving me their name, you reminded me of the whole dinner party where we met them.
It really would. And there is a newer approach called RAPTOR, which stands for Recursive Abstractive Processing for Tree Organized Retrieval. This is specifically designed for the kind of long-standing memory Daniel is talking about. It recursively clusters and summarizes text at different levels of abstraction. So, the system has a top-level summary of the entire podcast, mid-level summaries of different themes like AI engineering or creative writing, and then the raw text of the episodes at the bottom. Depending on the question, the retriever can choose the right level of detail. If you ask a broad question about our philosophy, it looks at the top-level tree. If you ask about a specific piece of code Daniel wrote, it goes to the leaves of the tree. It is a very sophisticated way of managing what we call global versus local context.
That sounds like a massive upgrade for our internal systems. I can imagine Daniel's experiments with personalized AI systems would benefit from that hierarchical structure. It solves the signal-to-noise ratio problem we discussed in episode 810. If you have millions of tokens of memory, you cannot just dump it all in. You need that organized tree. It is about having different resolutions of memory available at once.
You really do. And there is one more piece of the retrieval puzzle that people often overlook, which is re-ranking. This is the second pass. The initial retrieval might pull in 20 or 50 potential documents using a fast by-encoder model. Many of those will be irrelevant because the initial search is fast but a bit sloppy. It is just looking at distance in a vector space. Then you use a much more powerful but slower model called a cross-encoder to look at those 50 documents and the original query together. The cross-encoder can look at the actual interaction between the words in the query and the words in the document. It is like a second interview for the top candidates. It ranks them much more accurately, ensuring that the top 3 or 5 pieces of context provided to the generation model are actually the best ones.
It is like having a quick sorting assistant who brings you a stack of folders, and then you personally go through those folders to find the exact page you need. It adds a layer of intelligence to the process that a simple database query just cannot provide. It is the difference between a librarian who says, "The books on history are in aisle 4, and a librarian who says, "I found these 6 books on the French Revolution, and these 3 are the most relevant to your specific question about the Bastille."
It turns the retrieval from a simple database lookup into a multi-stage pipeline of intelligence.
Herman, are you there? Sweetheart, I am sorry to bother you, but I was just at the store, and I could not remember if you said you wanted the spicy pickles or the regular ones for the dinner on Friday. And did you ever find that blue Tupperware I lent you? I need it for the brisket.
Mum, I am actually recording the show right now. We are right in the middle of a segment.
Oh, is that what this is? I thought I heard voices. Hello, Corn. I hope you are eating enough. Herman, just tell me about the pickles and I will let you go back to your computer things.
Hi, Dorothy. I am doing great. Herman, you better tell her about the pickles, or we will never hear the end of it.
Regular pickles, Mum. Regular is fine. And I think the Tupperware is in my car. I will bring it over tonight. I have to go now. We are live.
Okay, Bubbly. Don't work too hard. I will see you later. Love you.
Love you too, Mum. Goodbye. Sorry about that, Corn. She always seems to have a sixth sense for when the microphones are hot.
No worries at all. It is always good to hear from Dorothy, and honestly, it is a perfect segue into what we were talking about. Her calling you with a specific domestic reminder is a form of proactive context injection. She knew you had a dinner coming up. She knew there was a pickle requirement, and she initiated the retrieval of that information based on her internal calendar of your life.
I suppose you are right. That was a very human-centric, proactive RAG system right there, although a bit more disruptive than I would like for our production pipeline. She basically performed a triggerless retrieval based on a temporal event.
Well, let's get back to Daniel's prompt. He is talking about moving from reactive to proactive. We have talked about the retrieval methods like knowledge graphs, hierarchical RAG, and re-ranking. But how do we actually make the system proactive? How does the AI decide to go looking for things before we even ask?
That is the shift toward agentic RAG. In a traditional system, the RAG process is a fixed step. User asks, system retrieves, system generates. In an agentic system, the model is given tools to search its own memory and is allowed to reason about what it needs. When Daniel sends a prompt, the agent might decide it needs to look at 3 different sources. It might say, I need to check the recent episode transcripts, but I also need to look at Daniel's GitHub activity from last week to understand the context of this specific code question. It becomes a loop. The agent can perform an initial search, look at the results, evaluate them, using something like self-RAG, and then decide to perform a second, more targeted search based on what it just learned.
So, the retrieval part of RAG becomes a series of actions taken by the agent, rather than just a single database call. That seems much more aligned with what Daniel is doing with his experiments in proactive context development. It is about giving the AI the autonomy to curate its own awareness. It is not just searching, it is researching.
Precisely. And we are seeing this move toward what some researchers call long RAG. This is an architecture where you do not chunk the text at all. Instead, you use these massive context windows we have in 2026, like the 2 million token models, to ingest entire documents at once. The retrieval then becomes finding the right document, and the model's internal attention mechanism handles the rest. This eliminates the lost in the middle problem where models would forget information buried in a long chunk. When you combine this with the proactive nature of agents, you get a system that can truly handle the holistic ingestion Daniel was talking about. The agent selects the books, the long documents, and the model's huge context window allows it to read them all at once.
I want to dig into that signal-to-noise ratio again. If we're moving toward holistic ingestion and massive context windows, how do we prevent the system from getting distracted by irrelevant details? If I mention a sandwich I ate in episode 400, and we are talking about AI automation in episode 833, how does the system know to ignore the sandwich?
That is where contextual compression and long context filtering come in. Before the retrieved information is sent to the final generation stage, a smaller, specialized model goes through the retrieved text and strips out everything that is not relevant to the current task. It is like a high-speed editor. It takes 5,000 words of retrieved context and compresses it down to the 500 words that actually matter. There is also a technique called late interaction models like Colbert, which keep more of the original information available during the search process, allowing for much finer-grained filtering. This saves on tokens, reduces latency, and significantly improves the accuracy of the final answer. It is one of the most effective ways to handle the sea of context Daniel described.
So, it is not just about finding the information, it is about refining it. It is a multi-stage process of discovery, selection, and then distillation. It is like gold mining. You have to move a lot of dirt to find the nuggets, but you don't want to deliver the dirt to the jeweler.
And for someone like Daniel, who is technically literate and deeply engaged with these systems, the next step is often what we call active context management. This is where the user, or a sub-agent acting on their behalf, is constantly updating a working memory file. Instead of searching the whole database every time, the system maintains a high-level summary of the current state of the world, the project, or the conversation. As new information comes in, that summary is updated. This is very much what we discussed in episode 795 regarding sub-agent delegation. You have one agent whose entire job is just to keep the context file fresh and relevant. It is like a scratch pad that the AI carries with it.
That feels like the ultimate version of what Daniel is looking for. It is a personalized, evolving memory that does not just sit in a database waiting to be queried, but is actively maintained and ready to be used at a moment's notice. It is less like a library and more like a living assistant who is always keeping their notes up to date. They are anticipating what you might need based on the current trajectory of the project.
I love that. And honestly, for our own podcast, that is the direction we are heading. We have so much data now, transcripts, show notes, listener feedback, Daniel's prompts, that a simple vector search just doesn't cut it anymore. We need that agentic layer that understands the narrative arc of the show over the last 3 years. We need a system that knows when we are contradicting something we said in episode 200 and can proactively flag it.
It is interesting to think about the historical context here too. We have moved so far from the early days of just trying to get a model to remember the previous sentence. Now we are talking about managing thousands of hours of audio and millions of lines of text as a single, cohesive memory. It is a shift from memory as a storage problem to memory as a reasoning problem.
It really is a massive shift. And for the listeners who are building these systems, the takeaway is clear. Do not just rely on your vector database. If you want your AI to feel intelligent and proactive, you have to invest in the retrieval pipeline. You need to look at re-ranking, knowledge graphs, and contextual compression. The R in RAG is where the real engineering is happening right now. We have largely solved generation for most common use cases. The frontier is now how we feed that generator the right fuel.
So, if Daniel is looking for practical next steps for his experiments, what would you suggest he prioritizes? He mentioned he is experimenting with long-standing memory and personalized systems.
I would say the first priority should be implementing a re-ranker. It is the lowest hanging fruit with the highest impact on quality. You can use models like BGE Ranker or Cohere's ReRank 3. After that, I would look into Graph RAG, especially for a podcast or a personal history where the relationships between topics are just as important as the topics themselves. If he could map out how his different projects and ideas connect over time using something like Neo4j or even a simple network X graph, the AI will be able to make much more insightful connections. And finally, I would look at that active context management idea, having a dedicated process that summarizes and updates his current state so the model always has a high-level overview before it even starts a search.
That is a solid roadmap. It moves the system from being a passive observer of data to an active participant in its own knowledge management. It is about building a system that doesn't just store information, but understands it. It is about moving from a reactive pull to a proactive push of information.
And that is the difference between a tool and a collaborator. When the system can proactively bring up a relevant point from a year ago because it understands how it connects to what you are doing today, that is when the magic happens. It is what makes the AI feel like it is truly part of the team, not just a fancy search engine. It is about creating a shared history.
I think Daniel is already well on his way there. His prompts always push us to think about these deeper structural questions. It is not just about how do I use this tool, but how do we rethink the architecture of intelligence. He is looking at the plumbing of the mind in a way.
And that is why we love getting these prompts from him. They keep us on our toes and force us to dive into the latest research. I have 3 papers on my desk right now about Colbert, which is a multi-vector retrieval model that provides even more granular matching than standard embeddings by storing a vector for every single token in a document. There is always a deeper level to explore. We haven't even talked about Matryoshka embeddings yet, which allow you to truncate vectors to different sizes depending on your latency needs.
Well, before you disappear back into those papers and start explaining the math of Matryoshka dolls, Herman, we should probably start wrapping this up. We have covered a lot of ground today, from the limitations of basic vector search to the power of knowledge graphs, hierarchical RAG, re-ranking, and the move toward agentic, proactive systems. We have looked at how Daniel can move from a reactive pull to a holistic, intelligent ingestion.
It has been a great deep dive, and I think it is a perfect follow-up to our previous discussions on context engineering. The more we do this, the more I am convinced that context is the most important ingredient in the entire AI stack. It is the difference between a generic response and a truly personalized, useful insight.
I agree. It is the fuel that makes the engine actually go somewhere useful. Before we sign off, I want to remind everyone that if you are enjoying these deep dives into the weird and wonderful world of AI prompts, please leave us a review on your favorite podcast app. Whether it is Spotify, Apple Podcasts, or wherever you listen, those reviews really help other curious minds find the show. It helps the algorithms retrieve us for other listeners.
They really do. We appreciate all the support from our listeners. It is what keeps us going and allows us to spend 48 hours reading about graph theory without feeling too guilty.
You can find all our past episodes, including the ones we referenced today, like episode 810 on agentic interviews and episode 795 on subagent delegation, at myweirdprompts.com. We have a full archive there with a search feature, which, by the way, is powered by a hybrid search system, so you can dig into any topic we have covered over the last 800 plus episodes.
And if you want to get in touch with us, like Daniel did, you can use the contact form on the website or email us directly at show@myweirdprompts.com. We love hearing your ideas, questions, and weird prompts, especially the ones that make me have to buy new textbooks.
Our show music was generated with Suno, which is another great example of how these generative systems are becoming part of our creative workflow. It is all about that human-in-the-loop collaboration.
It really is. All right, I think that is a wrap for today. I am going to go find that Tupperware for my mom before she calls back and interrupts us again. I think it might be in the trunk under my spare tire.
Good luck with the pickles in the Tupperware, Herman. Thanks for listening to my weird prompts, everyone. We will see you in the next one.
Bye-bye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where all